June 14, 1942. The desert sun hovered mercilessly above the dunes of El Alamein, casting harsh shadows over a landscape that had become a crucible for mechanized warfare. German reconnaissance patrols, elements of the Afrika Korps' 15th Panzer Division, crawled over the scorched sands in their Seung, Kfz 251 half-tracks and Kubelwagen, scanning the horizon for signs of the Allies. The air shimmered with heat, the scent of gasoline and engine oil mingling with the dust that coated every uniform and vehicle. It was in this desolate expanse that a small group of American vehicles lay abandoned, their white stars stark against the faded olive-drab paint. A Ford and a few Dodge staff cars had already been stripped for parts, but one vehicle in particular drew the attention of the patrol. A diminutive, open-top Willys MB Jeep, its canvas top torn, tires half buried in sand, yet otherwise intact. An Amerikanisch Spiel, muttered Lieutenant Fritz Huber, the reconnaissance officer leading the patrol. A toy? How could this ever serve in a real battlefield? His gaze lingered on the vehicle's compact engine, the hood slightly ajar, revealing the Go Devil Flat 4 engine, a small 60-horsepower unit that seemed absurdly underpowered for the task of desert warfare. Despite his derision, the practical mind of Oberfeldwebel Heinrich Claus recognized the potential. It's light, and look at the suspension. It might, just might, survive where our vehicles would bog down. He crouched beside the Jeep, running a hand along the fender. The frame was thin but solid, and the body panels, though lightweight, appeared to be welded and riveted with precision. Within hours, the Jeep was carefully dismantled of any usable supplies and towed back to a captured Italian maintenance depot, near Tobruk, commandeered for use by the German engineers attached to the Afrika Korps. The depot itself was a makeshift compound of sandbag fortifications and abandoned warehouses filled with the detritus of war. Dismantled tanks, trucks, and the occasional Allied vehicle awaiting examination. Here, the Jeep would meet its first formal scrutiny by the vehicle specialist, a 38-year-old mechanical engineer with a reputation for exacting precision, assigned to lead the evaluation. Weber had spent the previous 4 years analyzing French and Soviet vehicles for weaknesses, and his reports were often cited at the Oberkommando des Heer. On June 15th, Weber arrived at the depot, notebook in hand, accompanied by a cadre of mechanics and junior engineers. The Jeep was to be the centerpiece of a study into Allied mobility. "We are not here to destroy," Weber instructed, his voice measured but commanding, "but to understand. Every bolt, every gear, we must know if it is weakness or innovation." The first impressions were predictably skeptical. The Go Devil engine, with its 2.2-liter displacement, air and water-cooled cylinders, and compact flat 4 configuration, seemed laughably small compared to the 3.6-liter flat 6 engines of the Kubelwagen or the 4-cylinder engines powering the SDU 250s. "This engine will not survive 10 kilometers in the desert under load," one junior engineer, Dietrich Kleine, commented, tapping the engine block with a gloved hand. Yet Weber remained silent, flipping open his notebook and sketching the layout of the Jeep's chassis. The frame was unmistakably rigid for its weight, constructed from stamped steel beams reinforced at critical stress points. Unlike the German light vehicles, which relied heavily on precise tolerances and exacting assembly methods, the Jeep's construction favored simplicity and field repairability. Bolts were large, easily accessible and designed to be removed without specialized tools. An engineer's nightmare, or a soldier's boon, depending on perspective. Weber moved around the Jeep, inspecting the suspension. Independent leaf springs on each wheel provided an unusually high ground clearance, approximately 9.5 inches, enough to traverse dunes and rocky outcrops without bottoming out. The axles were sturdy, yet the lightweight nature of the vehicle meant that the engine's torque would rarely exceed the grip of the tires, reducing wear and increasing reliability. "Notice the simplicity," Weber murmured almost to himself. "No fancy hydraulics, no unnecessary complexity, just function." He jotted notes on the operational geometry of the suspension and the articulation angles of the front axle. Even the steering column, simple by German standards, allowed, for a surprisingly tight turning radius, a quality that would be invaluable in close-quarter desert maneuvers. Historical context framed their evaluation. By June 1942, the Americans had already begun supplying their British and Free French allies with vehicles through the Lend-Lease program. Mobility in North Africa was a constant challenge. Soft sand, sudden riverbeds, and a scarcity of reliable roads made wheeled transport a strategic asset. German vehicles, while mechanically superior in some respects, often suffered from overcomplication and lack of mass-producible simplicity. The Jeep represented a radical departure, a lightweight, rugged, multi-purpose platform designed not for perfection, but for resilience and utility in unpredictable conditions. Klause, now bending over the front axle, attempted to lift the Jeep by the bumper, marveling at how little it weighed. "If only our vehicles could move like this over dunes without straining every component," he muttered. Weber nodded, but said nothing. He was already imagining tests, torque measurements, load capacities, suspension articulation under simulated combat conditions, and engine stress runs in extreme heat. The initial inspection concluded that the Jeep, though modest in size and engine output, possessed a combination of features that German engineers found increasingly unusual. A rigid yet light frame, simple but effective suspension, and a powertrain designed for reliability rather than sophistication. Every note in Weber's log carried a tone of incredulity. A 60-horsepower engine moving a 1,100-kilogram vehicle across desert terrain seemed impossible. Yet the evidence in front of them was undeniable. As the sun set, behind the endless dunes casting long shadows over the depot, Hauptingenieur Weber stepped back and observed the Jeep. The mechanics busied themselves cataloging components and cleaning sand from the engine bay, while junior engineers debated the merits of American design philosophy. For Weber, however, the day ended with a quiet acknowledgement. This small, unassuming vehicle might hold more secrets than any tank they had ever examined. And so, in the scorched sands of North Africa, under the unforgiving glare of the desert sun, the stage was set. A simple American Jeep, designed for speed, versatility, and resilience, had been captured by German engineers who would soon discover that the true measure of a machine was not in its complexity, but in its ability to survive the impossible. July 2, 1942. The desert around El Alamein had become a makeshift proving ground. Hauptingenieur Carl Weber oversaw a team of engineers, mechanics, and logistics officers as they prepared the captured Willys MB Jeep for its first real field trials. The goal was clear: to evaluate not just the mechanical integrity of the vehicle under controlled conditions, but its practical performance across the harsh terrain of North Africa. The engineers had spent weeks cataloging components, measuring tolerances, and recording observations. Now it was time to see how theory translated to reality. Weber, clipboard in hand, directed the team as they loaded sandbags to simulate the weight of a fully equipped crew. The Jeep, still bearing traces of desert dust from its previous abandonment, seemed almost unassuming against the golden backdrop of dunes and scattered scrub. Weber's first test focused on mobility across uneven terrain. He drove the Jeep himself, carefully navigating ridges of compacted sand, gullies carved by intermittent flash floods, and rocky outcrops that would have immobilized a heavier vehicle. The mechanics observed the vehicle's response, noting suspension flex, wheel articulation, and chassis stress. The results were astonishing. The suspension maintains tire contact across extreme, uneven surfaces, noted Weber, his handwriting sharp and precise in the notebook. Independent front suspension absorbs shocks without compromising stability. Weight distribution is remarkable for such a compact frame. The Jeep's lightweight design allowed it to accelerate quickly over soft sand, unlike heavier German staff cars, which often bogged down under similar conditions. Weber paused on a ridge, squinting at the horizon, then steered sharply downhill. The tires sank slightly, but regained traction almost immediately. "Remarkable," he muttered. "The Americans may have discovered a balance of lightness and durability that we have not yet mastered." The team then conducted endurance testing. Engines ran for hours at high RPM, sometimes with repeated stops and starts to simulate the demands of desert reconnaissance and supply missions. The Go Devil engine remained unfazed. Cooling fins radiated heat efficiently. Carburetor adjustments proved unnecessary, and fuel consumption remained consistent even under extreme load. Weber compared these results with the specifications of German reconnaissance vehicles. The contrast was stark. American design prioritized field reliability over mechanical complexity, an approach that often gave them a practical advantage in prolonged campaigns. After several days of desert trials, Weber decided to test an idea that had intrigued him since inspecting the vehicle: the Jeep's water-crossing capability. Rumors among the captured manuals and American field guides suggested that the vehicle could ford streams and shallow rivers. But Weber wanted empirical data. To test this, the engineers constructed a temporary trench filled with water deep enough to submerge the engine halfway. Kloos, a young mechanic with a fascination for experimental tests, stepped forward nervously. "Are we certain this won't destroy the engine?" he asked. Weber's eyes gleamed with quiet anticipation. "We are engineers," he said. "We observe, we measure, we record. If the Americans designed it for shallow water operations, we will know soon enough." The Jeep rolled slowly into the trench. Water lapped against the frame, the tires churning mud and silt. The engine, mounted high on the chassis, continued to hum steadily. Weber and his team watched incredulous as the vehicle traversed the trench without sputtering or faltering. "Maintain RPM," Weber instructed. "Do not reduce throttle." The vehicle emerged from the trench, mud and water dripping from its undercarriage, but the engine showed no signs of distress. Mechanic after mechanic approached to examine the spark plugs, the carburetor, and the air intake. Everything remained functional. The Jeep had not only survived partial submersion, but had done so without any special preparation. "This is beyond anything I expected," Weber admitted quietly, almost to himself. "A standard vehicle, no modifications, capable of operating in water that would immobilize our light staff vehicles. The Americans have accounted for terrain versatility in a way we have dismissed." Encouraged by this first success, Weber ordered a more ambitious test. They constructed a deeper trench and gradually increased the water level, simulating a stream approaching 18 to 20 inches deep, a depth that had grounded many German motorcycles and light transport vehicles. To everyone's surprise, the Jeep continued to function, the engine maintaining power, the chassis resisting water pressure, and the electrical system operating without short-circuiting. Mechanics took turns examining components afterward, trying to identify the hidden trick. Some suggested waterproof gaskets or sealed ignition points, but Weber's careful analysis revealed no exotic engineering. Instead, it was the combination of a high-mounted air intake, simple ignition, and compact engine design that allowed the vehicle to endure conditions that would typically disable heavier or more complex vehicles. Weber's notes for the day grew increasingly detailed, capturing observations that would later become central to German studies of Allied engineering. By the evening, the team had established a routine. Vehicles were loaded with weights, driven through sand, subjected to desert heat, and then tested in water trenches. Each test reinforced a growing realization: the Jeep's mobility and versatility were exceptional, and its design philosophy, simplicity, ruggedness, and adaptability could not be replicated easily. At sunset, Weber walked along the line of engineers and mechanics reflecting on the progress. He could hear distant artillery in the north, the reminders of the ongoing desert campaign. Yet here in this isolated depot, a small American vehicle had captured the full attention of some of Germany's finest engineers. "Tomorrow," Weber said to the assembled team, "we will begin endurance tests under continuous operation. We will push this vehicle until it fails. Only then can we fully understand its limits." As the desert night descended, Weber returned to his tent with his notebook, scribbling sketches and calculations by the light of a single lantern. The Jeep sat quietly nearby, unassuming, yet it had already begun to reveal secrets that challenged everything the Germans thought they knew about Allied engineering and battlefield mobility. For the first time, many of the engineers admitted, albeit quietly, that the Americans might have out-engineered them, not with complexity, but with the practical brilliance of simplicity. August 10, 1942. The North African sun rose mercilessly over the captured maintenance depot outside Alamein. Hauptingenieur Carl Weber's team had settled into a rigorous testing schedule, pushing the Willys MB Jeep beyond anything previously attempted. The first desert trials and shallow water tests had already revealed its extraordinary mobility and partial water resistance, but Weber was determined to fully understand the limits of this unassuming American vehicle. The engineers began by focusing on engine endurance. The Go Devil, a 60-horsepower flat-4, was deceptively small, but Weber suspected its simplicity was a deliberate design choice. They ran the engine for continuous cycles of 6 hours under load, simulating the extreme conditions of desert patrols and reconnaissance missions. The air temperature hovered near 110 degrees Fahrenheit, yet the engine maintained normal operating temperatures with only minor oil expansion noted. Weber meticulously recorded oil viscosity, cylinder compression, and carburetor efficiency, noting that each metric remained within optimal ranges. "Observe the cooling fins," Weber instructed, pointing to the aluminum block. "Even under high ambient temperature, the engine disperses heat evenly. Minimal risk of warping or seizure." Next, the team moved to more ambitious water tests. They dug a trench simulating a shallow river, gradually increasing the depth until the engine was nearly submerged. This was not merely a test of endurance, it was a controlled experiment in forced submersion. Weber documented every variable: water pressure against the chassis, engine RPM, tire traction, and electrical system performance. Mechanics were astonished as the Jeep maintained full power, its small engine barely affected by the partial flooding. The high-mounted air intake and sealed ignition system allowed it to operate almost like a specialized amphibious vehicle. "It is not magic," muttered Weber to his assistant. "It is meticulous engineering. Every detail, from the intake to the frame height, contributes to its survivability." By mid-August, Weber began testing another feature that would later make the Jeep legendary: its ability to traverse fully submerged terrain. The engineers constructed a deep trench approximately 3 feet deep, deeper than any river crossing normally required. Sandbags were strapped to simulate cargo, and the vehicle was driven into the trench at full throttle. For the first moments, water poured over the engine compartment, flowing around the tires into the chassis' low points and threatening the electrical system. Mechanics held their breath. The Jeep plowed through the water without hesitation, emerging on the opposite bank with the engine running smoothly, exhaust gurgling, but no signs of water intrusion into critical components. Weber made detailed sketches of the engine layout, noting the positions of spark plugs, distributor, carburetor, and air intake. "This," he said quietly, "is a vehicle designed to think 2 steps ahead of the terrain." The Americans anticipated conditions we considered impossible for standard transport. Intrigued, Weber ordered further experimentation. They fitted a waterproof hood over the radiator and submerged the Jeep in a makeshift canal. For the first time, engineers were able to drive the vehicle almost completely underwater, at least to the depth of the axles and half the engine block. While not fully amphibious, it operated far beyond any comparable German vehicle. Weber calculated that in theory it could cross streams and shallow rivers that had previously halted German patrols, giving the Americans a critical tactical advantage. The success did not go unnoticed. Oberleutnant Friedrich Kramer, in charge of logistics for the depot, approached Weber. "Carl," he said, "this is extraordinary. If we could replicate even half of this engineering, it would change reconnaissance operations entirely." Weber nodded, though he remained cautious. "We can observe, we can document, but replication is not simple. This is simplicity perfected. Every component designed to withstand both desert and aquatic conditions. There is a reason they mass-produce these vehicles with such uniformity." That evening, the engineers reviewed their notes over dim lantern light. Water depth tolerance, engine endurance, weight distribution, suspension flex, and frame integrity were cataloged in meticulous detail. They even conducted small-scale tests on soft sand and shallow mud, confirming that the Jeep could navigate terrain that immobilized German motorcycles, light trucks, and even some armored cars. Meanwhile, Weber considered the strategic implications. The desert campaign was ongoing, and American forces were beginning to arrive in North Africa in larger numbers. A vehicle capable of high-speed cross-country travel, shallow water fording, and durable operation under extreme conditions could allow rapid troop movements, resupply, and reconnaissance, potentially altering engagements in the harsh desert theater. But for all its brilliance, The Jeep's true potential remained partially hidden. Weber suspected that the Americans had more tricks to reveal: modifications, operational tactics, or variants designed for river crossings and amphibious landings. He made a mental note to request additional captured units for study, hoping to uncover the full spectrum of capabilities. By the end of August, the testing was routine, but no less critical. Engineers rotated shifts, carefully observing engine wear, structural integrity, and water resilience. Each successful test reinforced a growing respect, bordering on astonishment, for American engineering. Even the most skeptical mechanics began to quietly acknowledge the Jeep's superiority in practical battlefield mobility. Weber, alone in his tent late one night, wrote in his notebook, "The Willys MB is a study in effective design. Simplicity and adaptability, not brute force, define its capability under conditions that would immobilize heavier vehicles. It maintains operational integrity. Its potential in desert, mud, and river operations is exceptional. Understanding its design principles may inform future German engineering, though replication will require humility and observation." Outside, the desert stretched endlessly. The sun had dipped below the horizon, leaving a sky streaked with orange and purple. In the depot, the Jeep rested quietly, mud-caked and exhausted, but ready for the next day's trials. It had already rewritten German assumptions about small-engine vehicles in combat, proving that ingenuity and simplicity could outmatch size, power, and complexity. The chapter closed on a note of quiet revelation. In a remote desert outpost far from the front lines, German engineers were learning lessons that would echo across future battlefields. Lessons about the overlooked power of mobility, reliability, and design foresight. September 2nd, 1942. The desert air shimmered under a relentless sun as Hauptingenieur Carl Weber and his team prepared the Willys MB Jeep for the next phase of testing. The preliminary endurance and shallow water trials had impressed even the most cynical engineers. But Weber wanted definitive proof. Could this small American vehicle survive the extremes that German reconnaissance vehicles often failed under? The engineers constructed a grueling obstacle course at the edge of the captured maintenance depot. Sand dunes, rocky outcrops, deep washes, and a man-made water trench simulating a desert wadi had been carefully arranged. Additional cargo, including sandbags, spare ammunition boxes, and communication equipment, was loaded to simulate a full patrol load. The Jeep, now designated Fahrzeug Nummer 1, had already endured dozens of partial submersion tests. Today it would face a comprehensive stress test. The first trial was sand navigation. Unlike traditional European terrain, the North African desert challenged vehicles with loose, shifting sand. German Kübelwagen and light trucks often became bogged down or required towing assistance. The Willys MB, however, maneuvered effortlessly. Weber noted the combination of narrow, high-traction tires, lightweight chassis, and independent suspension allowed the vehicle to float atop soft sand rather than dig in. "Observe the distribution of weight across the axles," instructed his assistant, Lieutenant Dietrich Müller. "The Americans understand weight placement better than any of our designs. No overloading, no tipping, just effective load management." Next came the rocky inclines. Engineers had created an artificial ridge of limestone boulders, ranging from 6 to 12 inches in diameter. Many German light vehicles would struggle, often suffering bent axles or broken leaf springs. The Jeep climbed steadily, engine humming, tires gripping each rock. Its leaf spring suspension absorbed shocks, and the robust frame showed minimal flex. "It is astonishing," muttered Müller. "I expected at least a broken frame or snapped axle." The most anticipated part of the day was the deep water trial. Engineers had dug a trench simulating a river crossing nearly 4 feet deep, higher than any previous test. Earlier experiments had demonstrated partial submersion was possible, but Weber now aimed to test full engine and axle immersion. Mechanics fastened waterproof ceilings over the carburetor and ignition system, and small fans directed airflow to prevent overheating during submersion. The Jeep was driven forward at moderate speed, entering the trench with careful precision. Water lapped against the hood, rushing around the tires, threatening to enter low points in the chassis. For a tense few seconds, the team held their collective breath. Then the Jeep surged forward. Engine and transmission functioned flawlessly. The exhaust gurgled audibly, water streaming around it, but the vehicle emerged on the opposite bank without stalling or damage. Weber examined every component immediately. Electrical connections were dry, engine oil had minimal water contamination, and suspension integrity remained intact. "Remarkable," Weber whispered almost reverently. "A vehicle designed to survive conditions we assumed impossible." Pushing the experiment further, Weber directed the mechanics to simulate mechanical failures while submerged. Tires were partially deflated, a spark plug was loosened, and one headlight was removed to examine water ingress. Even under these compromised conditions, the Jeep remained operational. Weber began drafting detailed schematics showing points of resilience and potential vulnerability, information that would later astonish German military engineers. As evening approached, the team recorded additional observations. High-speed runs across soft dunes revealed remarkable stability. Steep inclines demonstrated engine torque efficiency, and repeated waterfording tests proved the Jeep could function for extended periods under partial submersion. Weber noted the tires, chassis design, and engine layout all worked in harmony, a mechanical symphony of simplicity and effectiveness. By the end of the day, fatigue was evident among the crew, but admiration for the Jeep was universal. Weber convened a formal debriefing with Oberleutnant Kramer and other senior engineers. "Gentlemen," Weber began, his voice measured, "this vehicle exceeds our expectations in virtually every category. Lightweight, durable, amphibious to an extraordinary degree, and capable of operating under extreme conditions. Its design is deceptively simple but strategically significant. We must document every detail and determine if these principles can be applied to our own vehicles." Kramer nodded, impressed despite himself. "We have underestimated American ingenuity," he admitted. "This is not merely a light reconnaissance vehicle. In capable hands, it could shift the balance of mobility in any theater." As night fell over the desert, Weber wrote a detailed report for headquarters. He cataloged the Jeep's endurance, water submersion capability, and off-road performance. Sketches illustrated suspension geometry, engine placement, and air intake design. In a confidential note, Weber concluded, "The Willys MB demonstrates that simple, well-executed design can outperform heavier, more complex vehicles. Its amphibious capacity, structural resilience, and engine reliability present a new benchmark for tactical mobility. German engineers would do well to study it carefully, though direct replication will require careful adaptation to our operational requirements." Outside, the desert wind whispered through the dunes. The Willys MB rested, caked with mud and sand, engine still warm from continuous testing. It had endured more than any German light vehicle had in North Africa, yet it had only begun to reveal the full extent of its capabilities. Weber gazed at the Jeep, a mixture of respect and quiet envy in his eyes. He understood that in this unassuming machine, the Americans had achieved something rare, an elegant solution to the enduring problem of mobility in war. In a remote depot far from Europe under the scorching desert sun, a captured Jeep had quietly rewritten the rules of vehicle. Warfare, November 12, 1942. The captured maintenance depot, now repurposed as a German experimental vehicle site, lay quiet beneath the early morning haze. Hauptingenieur Carl Weber had spent weeks compiling test data, but a new question gnawed at him. If the Jeep could survive shallow water crossings, how far could its capabilities extend? Could it, in theory, operate under full submersion, not merely for seconds but long enough to cross a river or survive unexpected flooding? The Germans had seen firsthand the limitations of their own amphibious designs. Schwimmwagen and half-tracks were competent, but they relied on added complexity and were prone to mechanical failures when submerged. The Jeep, by contrast, exhibited remarkable resilience during partial fording tests. Weber's engineering mind began envisioning a more ambitious experiment, one that would stretch conventional logic, a controlled, fully submerged drive. "Gentlemen," Weber addressed his team, gathered around a sand-laden Willys MB. "Our observations suggest that the Americans have incorporated design features allowing water ingress without catastrophic failure. I propose a series of tests to determine if the engine, drivetrain, and electrical systems can function under prolonged submersion." Skepticism rippled through the engineers. Oberleutnant Kramer, a veteran of North African campaigns, shook his head. "You are suggesting we drive it underwater, Weber. This is madness. We have never attempted such a procedure on any vehicle. Ours fail at half the depth of that trench. Weber's eyes were unwavering. Precisely because it is unprecedented, we must explore it. Our reports may inform the design of future reconnaissance vehicles, or reveal weaknesses in enemy technology we can exploit. Preparations began at the edge of a shallow desert wadi fed by a seasonal runoff. Engineers dug a trench exceeding 5 feet in depth, wide enough to accommodate repeated trials. They waterproofed sensitive components, sealing ignition points, carburetor intakes, and the distributor. Special hoses were attached to extend air intake above the waterline, and a rudimentary exhaust snorkel was fashioned from salvaged tubing. Every precaution was calculated, every potential point of failure noted. Lieutenant Dietrich Müller, assigned as the driver for the experiment, adjusted his goggles and gloves. He had practiced for hours in partial submersion runs, and his confidence in the Jeep had grown. Yet the magnitude of this test caused even him a subtle unease. The vehicle rolled forward, tires gripping the sandy floor as the front wheels entered the water. Slowly the trench engulfed the chassis. Water lapped against the hood, rushing over the fenders. Sensors and gauges mounted by Weber's team monitored every function: engine temperature, oil pressure, exhaust flow, and electrical continuity. The Jeep moved steadily. The engine hummed, transmission engaged, and no immediate signs of malfunction appeared. Weber and his assistants leaned close, eyes scanning for any irregularities. The water reached the wheel arches, then the doors. Yet the vehicle pressed forward with a silent insistence, cutting through the wadi like a small but determined submersible craft. "Remarkable," Weber whispered, scribbling notes in his log. "The Go Devil engine continues to run without loss of power. Electrical circuits remain operational. Drivetrain fully engaged." Minutes passed. Muller maintained a slow, deliberate speed, ensuring the engine did not ingest water through the extended air intake. Observers noted that the Jeep's weight distribution and high ground clearance prevented water from entering critical points. The independent suspension absorbed minor underwater turbulence from the current. Suddenly, the Jeep hit a submerged sand ridge. The vehicle shuddered but did not stall. Tires spun momentarily, then gripped the sediment and continued forward. Weber allowed himself a rare smile. The data was undeniable. The Jeep could operate in water far deeper than any contemporary German vehicle of similar size. After several passes, Weber convened a team debrief. He outlined the mechanical principles that made this possible: lightweight frame reducing chassis stress, a sealed Go Devil engine with minimal exposure points, air intake placement above likely submersion levels, and a drivetrain tolerant of temporary water exposure. Every observation reinforced a simple truth. The Americans had created a vehicle far ahead of its apparent simplicity. Kramer, still skeptical, asked the question Weber had anticipated. "And what does this mean operationally? How can a Jeep survive full submersion in combat?" Weber paused, choosing his words carefully. "It is not merely a question of surviving water. This capability grants the Jeep a tactical advantage no other light vehicle possesses. Reconnaissance units can cross rivers without bridges, evade obstacles previously deemed impassable, and recover from sudden flooding without loss of mobility. In essence, it is amphibious in a way that approaches true submersible function, though not in the sense of a submarine. It can traverse conditions that would immobilize all others." Muller added with a mix of awe and humor, "So you're telling me, Herr Weber, the Americans built a Jeep that can drive underwater?" Weber's gaze was steady, almost reverential. "Yes, Lieutenant, and we are the first to confirm it. Document it carefully. This knowledge is not merely academic. It has implications for battlefield mobility and engineering principles that we cannot ignore." That evening, Weber prepared a classified report for the Oberkommando des Heers. Detailed sketches illustrated suspension geometry, engine sealing points, and air intake configuration. Notes described every trial, including water depth, engine RPM, and load conditions. His concluding observation carried a note of quiet respect. "The Willys MB demonstrates a level of engineering foresight rare among modern vehicles. Its capacity to operate under complete submersion without failure challenges conventional wisdom and sets a new benchmark for tactical mobility. Future vehicle designs should consider similar principles, for the Americans have achieved a remarkable balance of simplicity, durability, and innovation. Outside the depot, the desert wind stirred the sand. The Jeep, caked in mud and water, rested quietly, an unassuming testament to American ingenuity. Weber looked at it long after the engineers had left, pondering the implications. A small 60-horsepower engine, a lightweight frame, and carefully considered design details had created something the Germans could neither have anticipated nor easily replicated. In the harsh North African theater, a captured Jeep had silently rewritten the rules of vehicle mobility, and in doing so, hinted at a new era of engineering thought. December 3, 1942. Luftwaffe headquarters in Berlin. The city was gray and cold, its streets slick with winter rain. Inside the ornate but austere conference room of the Heereswaffenamt, Hauptingenieur Carl Weber prepared to present his findings. A small battered Willys MB Jeep sat in the courtyard outside, shipped in pieces from North Africa under heavy guard. Engineers, logisticians, and high-ranking officers gathered to witness firsthand a vehicle that had already begun to rewrite conventional notions of mobility. Weber adjusted his glasses and began his briefing. Gentlemen, the vehicle before you is a captured Willys MB, standard issue to American forces in North Africa. Initial inspection suggested a simplistic design, a 60-horsepower Go Devil flat-4 engine, lightweight chassis, and minimalistic suspension. We expected a novelty at best, a curiosity to occupy technicians between more serious tasks. A murmur of skepticism ran through the room. Colonel von Richter, a veteran of armored divisions, leaned back in his chair. So this is merely a Jeep, Herr Weber. Surely we have more pressing matters than examining a foreign utility vehicle. Weber nodded, acknowledging the sentiment. Understood, Colonel. However, what we discovered challenges these assumptions. In controlled trials, the Jeep demonstrated operational capacities that exceed any light reconnaissance or transport vehicle currently in German service. The engineers seated along the conference table exchanged intrigued glances. Weber's report, thick with handwritten diagrams and charts, was placed in front of each of them. He began to outline the North African testing sequence. Acceleration, trials on sand, gradient climbs under full load, and most notably submersion experiments in desert wadis. Each page displayed meticulous measurements: engine RPM, oil temperature, wheel torque, and water ingress tolerance. The key discovery, Weber continued, is the Jeep's ability to maintain engine operation while partially submerged, a depth exceeding 5 feet. Electrical systems remain functional, and the drivetrain maintains full engagement. Tires maintain traction even under submerged sand conditions. In short, the vehicle can traverse flooded terrain that would immobilize any comparable German vehicle, including Schwimmwagen and half-tracks. A senior engineer, Oberingenieur Franz Becker, raised a hand. You are implying the Americans built a vehicle capable of functioning underwater. This borders on the impossible. Even our amphibious designs fail when submerged beyond shallow fords. Weber held the room's attention with quiet precision. We confirmed the capability empirically. Modifications to the engine air intake and exhaust were minimal, and the Go Devil engine's simplicity allows for high tolerance of water exposure. The independent suspension and high ground clearance contribute to the vehicle's mobility across uneven, partially submerged terrain. It is, in effect, a practical submersible reconnaissance vehicle, albeit not a submarine. Yet in tactical terms, its resilience is unprecedented. Von Richter's eyebrows rose, betraying both disbelief and a grudging respect. And you are confident this is not a fluke, Weber? I am confident, Weber said, producing a series of photographs taken during the North African trials. The Jeep, half-submerged, navigated a muddy trench without hesitation. Every test was repeated multiple times. We documented each variable: water depth, load, engine speed, and chassis stress. The results are consistent. The design tolerates conditions that would otherwise disable conventional vehicles. He paused, letting the information sink in. The room fell silent, the only sound the scratching of pens across paper and the low murmur of officers absorbing the implications. Von Richter leaned forward. "And what does this mean for German operations?" Weber exhaled carefully, choosing his words. "It means the Americans have achieved a level of tactical mobility and engineering foresight that surpasses our current designs. Their light vehicle can traverse rivers, marshes, and flood-prone areas without bridges or additional engineering support. In North Africa, this capability could allow reconnaissance units to outmaneuver our forces with minimal risk to their mobility." Becker frowned. "Are you suggesting we replicate this? Or is it merely a curiosity?" Weber's voice was calm but firm. "It is neither merely a curiosity nor a simple blueprint for replication. The design principles, lightweight frame, high ground clearance, independent suspension, minimal points of mechanical failure, are as valuable as the vehicle itself. Future German reconnaissance and utility vehicles should incorporate these principles. Ignoring them would be a strategic oversight." Von Richter leaned back, steepling his fingers. "You leave us with an uncomfortable truth. The enemy's engineering is superior in a domain we have considered trivial. And yet this is a Jeep, a vehicle that could be shipped by the ton in Lend-Lease programs and quietly alter battlefield mobility." Weber nodded. "Exactly, Colonel. In combat, mobility equals survival. The Americans understand this implicitly. Their engineers designed a vehicle to endure conditions most would consider extreme, and they did so without overcomplication. Our own designs, by contrast, require multiple specialized vehicles or cumbersome modifications to achieve comparable results." A quiet murmur rippled through the assembly. Some engineers whispered among themselves about the implications: river crossings in Eastern Europe, flooded fields in Normandy, even jungle operations where conventional vehicles would fail. Weber listened, but allowed the room to absorb the revelation. He concluded, "The Willys MB is more than a vehicle. It is a testament to efficiency, foresight, and simplicity. Its performance under conditions we considered prohibitive is a lesson in design philosophy. Our task now is to study it, document it, and understand which principles can inform German engineering, without losing sight of practicality or battlefield necessity." Von Richter gave a reluctant nod. "Very well, Weber. Ensure the report reaches the Oberkommando des Heeres. I want a copy delivered to all relevant design bureaus, and an operational summary prepared for field units. If these capabilities are as you describe, they cannot be ignored." As the meeting adjourned, Weber lingered, sketching additional diagrams and noting observations for later analysis. The Jeep outside, disassembled for transport, was deceptively ordinary. Yet in every welded joint, every rivet, every inch of suspension travel, it carried lessons that could reshape German vehicle doctrine. Berlin, with its frost-lined streets and winter fog, seemed unaware of the small revolution taking place within its halls. A captured American Jeep, underestimated by all who first saw it, had quietly revealed engineering truths the Germans had not anticipated. In doing so, it would influence design thinking far beyond the deserts of North Africa, leaving a legacy that would quietly echo through armored and reconnaissance vehicles for years to come. February 12, 1943. The North African sun had begun its slow retreat toward spring, but the desert remained a harsh tutor. Hauptingenieur Carl Weber returned to the captured maintenance depot near Alamein, this time accompanied by Oberingenieur Franz Becker and a small detachment of motorized infantry officers. Their goal was clear: test the Willys MB Jeep in conditions approximating operational deployment and assess how its design could inform German vehicle development. The Jeep had been carefully reassembled after its journey to Berlin, with additional modifications for extended trials. Engineers had installed gauges to monitor engine temperature, water ingress, and drivetrain stress. Cameras, a rarity in field experiments, were positioned to record suspension movement and wheel traction under sand and mud conditions. "Weber," Becker said, brushing sand from his coat, "I still find it remarkable that a 60-horsepower engine can traverse dunes without stalling, while our Kübelwagen often struggle with half that incline." Weber nodded, examining the Jeep's engine bay. It is not merely the engine power, Franz. Note the weight distribution and chassis flexibility. The frame can absorb uneven terrain without transmitting destructive stress to the drivetrain. Our vehicles are rigid by comparison, which makes them more vulnerable in soft sand or rocky wadis. The first trial commenced at dawn. Weber and his team loaded the Jeep with sandbags to simulate combat equipment, radio sets, ammunition crates, and field rations. A team of observers marked the course through a mixture of soft dunes, rocky ridges, and narrow wadis. As the Jeep climbed its first slope, wheels spinning slightly but never stalling, Becker muttered, "I will admit it performs admirably, almost too easily." The vehicle navigated the course without incident. Sand, rocks, and debris were no match for its suspension geometry and high ground clearance. Every movement of the vehicle was captured by film cameras, each shot to be analyzed for suspension articulation, torque distribution, and frame flex. The second test was more ambitious: water fording. Weber directed the Jeep into a shallow wadi that had collected rain from the previous week. The water level, initially knee-deep, gradually deepened into a trench approaching 5 feet. The German engineers watched anxiously. Conventional German light vehicles, including Schwimmwagen, often failed at these depths without extensive waterproofing or auxiliary equipment. The Jeep continued forward, engine humming steadily, tires gripping sand beneath the water. Electrical components, including the ignition and lights, functioned without interruption. Observers jotted notes furiously. Water did not enter the carburetor or exhaust in a manner that impaired function, and the drivetrain maintained torque across all wheels. Becker exhaled slowly. It's operational in water deeper than our engineers ever expected from a light reconnaissance vehicle. Weber's eyes were fixed on the data gauges. Notice the simplicity of the Go Devil engine. Few moving parts, minimal points of failure. That combined with waterproofed electrical circuits is what allows this vehicle to maintain function where ours would falter. The final test involved high-speed maneuvers through irregular terrain, simulating reconnaissance evasion and rapid troop transport. The Jeep darted across sand ridges and rocky outcrops, the suspension absorbing every jolt. The engine's low center of gravity combined with a short wheelbase allowed precise steering even under full load. By late afternoon, Weber and Becker convened the team. Notes were exchanged, diagrams sketched, and calculations recorded. The consensus was unanimous. The Willys MB was operationally superior to German equivalents in multiple mobility domains. However, the team also identified limitations. The engine is underpowered when fully loaded, Weber noted. It is sufficient for reconnaissance or light transport, but for heavier loads, the Germans' Kübelwagen or half-tracks remain necessary. Additionally, the simple gearbox limits speed and torque multiplication compared to our more complex designs, Becker added. Yet the Jeep's adaptability compensates for these weaknesses. Any modification to German vehicles must focus on simplicity, durability, and mobility over raw horsepower. Following the trials, the Germans attempted limited replication. A small number of prototype vehicles were modified with lessons gleaned from the Willys MB, increased ground clearance, simplified suspension, and waterproofed ignition systems. Yet, due to wartime resource constraints, production of these adapted Kübelwagen remained experimental. Weber's team documented every trial in painstaking detail, submitting extensive reports to the Heereswaffenamt in Berlin. During the last week of February, Weber conducted a final demonstration for field commanders. A convoy of mixed vehicles, half German, half-adapted prototypes, navigated the same course. Observers noted the differences in traversal speed, suspension stress, and reliability. The Willys MB consistently outperformed every German vehicle under testing conditions, particularly in soft sand and waterlogged terrain. One officer, Hauptfeldwebel Dietrich, remarked quietly, "It is astonishing that the Americans designed something so simple yet so effective. Our engineers spend months calculating torque ratios and suspension geometry. Yet this Jeep does more with less." Weber agreed, though with a professional detachment. "Effectiveness is not a question of complexity, Hauptfeldwebel. It is a Question of design philosophy. Anticipating battlefield conditions, tolerating environmental extremes, and ensuring functionality under duress. The Americans understand this instinctively. By the end of February, the field trials concluded. The Willys MB had proven its operational capacity beyond theoretical speculation. Its performance in sand, rocks, and water demonstrated a combination of reliability, adaptability, and durability that German engineers could scarcely ignore. Every sketch, every measurement, and every recorded observation was archived, forming a reference point for potential future vehicle development. March 3, 1943, Berlin. The war in North Africa had reached a stalemate along the Alamein line. But in the quiet halls of the Heereswaffenamt, a different kind of battle was taking place. A battle of ideas. Hauptingenieur Carl Weber and Oberingenieur Franz Becker had traveled north from the desert, bringing with them the captured Willys MB Jeep, detailed field reports, sketches, and photographic evidence from weeks of rigorous testing. The vehicle itself was crated and transported by rail, a conspicuous but necessary effort to maintain its condition. High-ranking engineers, armored vehicle specialists, and even representatives from the Wehrmacht's motorized infantry units gathered in the office of General Major Wilhelm Hensel, head of the Engineering Evaluation Department. The air was thick with cigarette smoke and the tension of anticipation. Few had seen the results firsthand, and many expected exaggeration. Weber began his presentation with a precise outline: construction, suspension geometry, engine reliability, and performance under extreme conditions. Slides of the desert course were projected: sand dunes, rocky ridges, and shallow wadis, each annotated with speed, engine temperature, and ground clearance data. "Gentlemen," Weber began, his voice measured but carrying the weight of his desert experience, "we have in our possession a vehicle that defies conventional German engineering assumptions. The Willys MB, though small and seemingly underpowered, demonstrates operational flexibility and durability that surpass many of our light vehicles in North Africa." Becker interjected, "It is not merely the engine or the frame, but the philosophy of its design. Simplicity ensures reliability. Lightweight construction allows traversal of terrain that would immobilize heavier vehicles. Electrical components are minimally exposed and effectively waterproofed. Suspension articulation and chassis flexibility allow high-speed maneuvers over irregular terrain without structural failure." A senior engineer, Oberleutnant Kraus, leaned forward, skeptical. "And what of its armament potential? Its payload capacity? A reconnaissance vehicle must carry not only equipment, but defensive weaponry." Weber nodded. "Indeed, it carries up to 800 kilograms of payload, which includes radio equipment, ammunition, and a small crew. Its compact size allows maneuverability in confined areas where our Kübelwagen or S-Stikavzaden vehicles are hindered. Armament can be mounted if necessary, though the vehicle's strength lies in mobility and reliability, not firepower." Hensel, tapping a pencil against the desk, asked the question that weighed on all minds. "Can we replicate this vehicle? Our production lines are already strained. Can German factories produce a comparable model without compromising our existing output?" Becker's response was pragmatic. Full-scale replication is unlikely during wartime. However, selective adaptation of key principles, ground clearance, suspension design, simplicity of engine components, waterproofing, could inform the next generation of German reconnaissance vehicles. It would not be a direct copy, but a conceptual integration. Discussion turned to logistics and strategic implications. The German supply chain in North Africa, and indeed across Europe, was often hampered by vehicle breakdowns in desert conditions. The Willys MB's endurance suggested that incorporating similar design principles could increase operational tempo, reduce mechanical attrition, and improve reconnaissance effectiveness. A quiet murmur arose among the observers when Weber revealed the most striking data: the Jeep's performance in water. "Our Schwimmwagen were innovative," Weber explained, "but they are limited in depth and require complex maintenance. The Willys MB forded trenches up to 5 feet deep without preparation. Electrical systems, engine function, and drivetrain integrity remained intact. In desert operations, flash floods and wadis render many of our vehicles inoperable. This vehicle's resilience changes that equation." Hensel paused, considering the implications. "If the Americans can mass-produce such a simple yet effective vehicle, Our industrial efforts may need to reconsider the balance between complexity and operational utility. Resources spent on sophisticated systems may not yield equivalent battlefield returns. The team then reviewed German replication efforts in North Africa. Prototype-adapted Kübelwagen, incorporating increased ground clearance, simplified suspensions, and waterproofed ignition, were evaluated. While promising in concept, they had not achieved the same level of reliability as the Willys MB under identical field conditions. Production limitations and material scarcity constrained further development. Hensel turned to Weber. And the men, morale and ease of use. Can German troops operate such a vehicle effectively? Weber smiled faintly. That is another lesson. The Willys MB is intuitive. Minimal training allows soldiers to operate, maintain, and repair the vehicle in the field. Spare parts are accessible. Engine design is straightforward. In contrast, German light vehicles require extensive instruction and maintenance protocols. In operational terms, simplicity equals efficiency, and often survival. Becker added an observation from the desert. Our men, accustomed to heavier vehicles, were surprised at the Jeep's agility. Quick maneuvers, fast recovery from sand or mud, and low mechanical failure all contributed to a sense of reliability. Soldiers trust a vehicle that does not fail unexpectedly. This factor is difficult to quantify but crucial for frontline operations. By late March, Weber and Becker submitted their final report to the Heereswaffenamt. It included detailed schematics, photographs, engine performance charts, and comparative analyses against German vehicles. The report concluded with recommendations. The report was met with cautious approval. Senior officers recognized the value of the findings but faced political and industrial challenges. Existing production lines, resource allocation, and the prioritization of armored and mechanized units constrained the immediate application of lessons learned. Yet the acknowledgement was clear. The Willys MB represented a paradigm shift in vehicle design philosophy. Outside the office, Berlin in March 1943 was cold and gray. Air raids were a distant threat, but a constant presence in daily life. Within the insulated halls of engineering bureaus, discussions of wheels, suspension, and engine reliability might have seemed trivial, but they touched on the broader strategic reality. Mobility was life and death in modern warfare. A small captured American Jeep had exposed shortcomings in German assumptions and provided lessons that, if heeded, could improve operational efficiency, or if ignored, leave German forces at a persistent disadvantage. Weber, returning to his quarters that evening, reflected on the journey from North Africa to Berlin. The Jeep had endured desert heat, sandstorms, wadi floods, and rigorous testing. Yet it remained intact, functional, and instructive. It was more than a vehicle. It was a lesson in practicality, resilience, and design foresight. And as the German High Command debated, the Americans continued mass-producing the Willys MB, thousands rolling off assembly lines in Detroit and Toledo, destined for battlefields across the globe, North Africa, Europe, and the Pacific. Every Jeep was a reminder that sometimes simplicity and ingenuity outpace complexity and tradition.